G'day. So, as waterproofers, we can only control wet film thickness. So, you need to understand how to calculate it from any technical data sheet. This quick video is just going to guide you step by step in a few ways that we can calculate this wet film that we need, because that's the only thing that we can control. So, what I call the triangle. We can calculate the wet film thickness from any two available bits of information. For example, if we know the coverage rate and the dry film thickness, the WFT, we can calculate the wet film thickness. Conversely, if we know the dry film thickness and the solids content, because that's all they've told us, we can also calculate the wet film thickness. And if we know the coverage rate and the solids content only, we can also work out the wet film thickness. So a triangle. We only need two bits of information to give us wet film thickness. So here's a typical, well, not a typical, this is a very good technical data sheet, TDS, from RLA Grip Set. Very clearly, a lot of information, yeah? So you need to understand it and read through it. But let's just highlight, let's drill down into the application and coverage, this area down here. Because that's the bit that we really, if we're applying it, that's the bit that we want to focus on. So let's just focus on that. So Gripset have very clearly told us how thick they want to apply it. There's been no confusion. You can see by the table there that the first coat has to go on at 750 microns and then followed by the second coat at a further 750 microns, very clearly. And if you add 750 and 750, you'll get 1500. And as a general rule, we can follow that general rule and say, well, that correlates to that 1.5 litres per metre squared that Gripset is telling us about. So you can see here, they've very clearly given us the information. We don't need to work out anything, which is very handy. Well done. What if a product gives us this blurb on their technical data sheet? We need to calculate it a bit more. We need to think more laterally and, a bit more deeper about it. So have a, if you read through it, you'll suddenly glean out the important bits of information that you need. The first bit of information I really want to focus on is this bit in red. The 1 by 15 litre pail will cover 10 square metres. That's the coverage or consumption. That's really the bones about it. What they're really telling us is that for every bucket of 15 litres, it's 15 litre bucket, it's going to apply across 10 square metres. So step one in calculating our wet film thickness coverage using coverage rates, these consumption rates. We divide the 15 litre by the consumption. So in this case, we're going to divide 15 by 10, and it's going to give us 1.5 litres for every 1 square metre. Step two is going to be convert the 1.5 litres per 1 metre squared to millimetres. It's a general rule, and we'll go through this deeper in the class. So essentially just multiply the 1.5 by 1 and you'll end up with 1.5 millimetres. We just add the millimetres to the end as a general rule. Step 3, convert that 1.5 millimetres to microns, because we work in microns when we're waterproofing. 1.5 times 1,000, because there's 1,000 microns in a millimetre. 1.5 by 1,000 gives us 1,500 microns. So all of a sudden we know in microns what our wet film thickness is. And from there, we just divide that by the number of coats. All liquid systems are 2 coat systems, minimum. So we divide 1,500 by 2, and we get 750 microns per coat. And there it is. You've worked out the wet film thickness from the coverage rates. So this product wants you to apply their material at 750 microns wet per coat. What if we want to know the solids content percentage, which is a good metric to have? Sometimes we just want to understand how thick this membrane is. We can get that information from the same blurb of information. Remember the triangle. We only need 2 bits of information to work out anything. So step 1, find the total dry film thickness requirement. In this case, it's 1 millimeter, the minimum dry film thickness of approximately 1 millimeter. Step 2 is find the total wet film requirement. From our previous calculation, we've calculated it out at 1.5 millimeters for a total. Step 3 is divide the dry film thickness by the wet film thickness. And we can see that we're going to divide 1 millimeter by 1.5 millimeters, and we end up with a decimal point, a decimal number, 0.667. Then we just multiply that by 100 to give us a percentage. So step 4 is just multiply step 3 by 100, and you'll end up with 66.7%. And again, just like that, you've calculated the solids content of this membrane as being 66.7% solids content. What does that mean? We'll find out in class. Say, for example, a product that only gives us dry film thickness and the solids content, just on the rare occasion that you might come across a membrane that's like that. Yeah, we can work out the wet film from there. Remember, we only need 2 bits of information. So step 1 is find the total dry film thickness requirement. In this case, it's 1.2 millimeters. Step 2 is find the solids content percentage. In this case, they've told us it's 60%. So then we do a bit of math. Divide the dry film by the solids. So in this case, we're going to divide 1.2, divide that by 60, and multiply it by 100. And we get 2 millimeters of wet film total. And then again, divide that by number of coats. All liquid systems are minimum 2 coats. So we divide the 2 millimeters by 2 coats, and we get 1 millimeter per coat wet. And just like that, we've calculated wet film thickness you need from the 2 bits of information. So as you can see, we've calculated, or we've shown multiple ways to get wet film. And remember, wet film is our go-to number that we need. We can only control wet. We can't control dry film because we're applying wet film all the time. Anyway, good luck. I'll see you in class.